Okay, friends, everybody should be done with maze, correct?
Yes.
Okay, go ahead and X out, close up your computers, put them in the desks, please. Okay, the next thing we are going to talk about is the data literacy quiz you took this morning. Okay.
Okay.
Do you have a question?
Can I redo it?
No. We'll talk about it and then you'll get a chance to do another one on Wednesday. Okay? I would like you to talk in your small groups. What is this graphic? What is it? What information is it giving us? So what's it about? What information is it giving us?
This thing is like the timeline of how NASA
It's like the timeline about how NASA's journey.
It's a timeline. So,
Yeah.
Alright, 4, 3, 2, 1, and 0. Asante, what did your table talk about?
it's highlighting and it's going through the journeys that pass through.
Okay. Let's add to that. Tassi, what can you add to Asante? What did your group talk about with this graphic? The year. Okay, so we see years on it. What tool gives us years like this?
Go by.
Would you know what this tool is called?
Go by.
Yeah, a timeline. Thank you. So this particular tool gives us years, right? Gives us an idea. What is it a timeline of?
It's
NASA. NASA's journey.
I got lots of people. Let me, Chloe, tell me.
Yes, it's a timeline of how NASA's journey began
How it began and
and how it is today.
how it is today. So when does this, when does this timeline start? Starts in the 1950s. Oh my gosh, that was a million years ago, wasn't it? Not quite. Malachi, how long does this timeline go?
70. 74 years.
So far, right? 74 years so far. We started at 1950. So we're going to use this timeline to answer some questions. One thing I want to point out is that with a good strategy for using a timeline is looking for little clues, right? You don't have to remember everything, but for example, if I look here, help the U.S. justify a space program, NASA is launched. What do you think the most important words from this section would be?
NASA.
So we've got NASA. What does launch mean as far as NASA's launch? Does that mean they're shooting all of NASA into space?
No, they're shooting apart. It's like when NASA space station.
Just the thought.
So, Lucy, what does it mean? What does this mean? NASA's launched.
It means that it means like people know it knows like when NASA was open.
Yeah, when it was created, right? So that's the first we ever had NASA was in the 1950s. Believe it or not, my friends, I wasn't born yet. Okay?
Yeah,
NASA's
so you're
older
not
than I am.
74-year-old.
NASA's older than I am. I am not a 74-year-old, thank goodness.
Misha, what are you doing retired?
Okay, so we're going to look at this quiz using this data, this graphic. And I'm going to ask a question. I'm going to have you talk about it with your team, and I'm going to call somebody to come up and choose the correct answer. So the first question is, which event happened first? first? The Apollo 2 moon landing, International Space Station assembly, Hubble telescope design, or Artemis mission to the moon? Talk at your table, please.
The answer
Apollo second. Apollo
4, 3, 2, 1, and 0. Baba, come choose my answer for me. And then I want you to tell me how you know. Oh wait, you didn't choose it. Try again. There we go. How do you know?
Because it's the first event that happened out of those ones.
Out of those choices. So, was there something that happened first?
Yes.
Yes.
The NASA when it launched.
NASA was launched first, but that's not a choice. Think about how you can sit down. Okay, the next one. You're going to put these events in order from what happened first to what happened most recently.
Okay,
So,
what happened first?
actually, let's go through this part quickly, okay? I'm going to call one person at a time to come do one. Alex, you're going to come do first. Just come do what was first.
It's easy.
Friends, check Alex's work and make sure you're prepared in case I call your name second. Oh, if you have to click on the dots right there, and then move it up to where it goes. So here's what I want to do. Looks like Alex is moving NASA was created into the first spot. If you agree with Alex, give him a thumbs up. Alex, looks like we have a lot of people agreeing with you. Yes, I have the magic touch. Try that.
Yeah, magic touch, but you have bad luck.
Okay, let's get somebody up here for the second. Wah. Which one do you think? Oh, so it looks like she's taking Apollo moon landing. If you agree with Wah, give her a thumbs up. Wah, turn and look and see how you did. Yep, looking good. Third up is Maya. What's third? Oh, it's already there? Thumbs up if you agree with Maya that the Hubble telescope was designed as number 3. Okay, let's have Asante come up and do number 4.
It looks like you.
Do you want to phone a friend?
You can phone me.
Phone your friend? Do you need support? Just ask her. Tell her.
Number 4 is International Space Station.
If you agree with Asante and MLA, go ahead and move that one. That it's International Space Station was assembled. Give her a thumbs up. Looking good. And my last one, oh, we should already be there. The last one is Artemis missions. So, friends, this is pretty easy. You just have to look for the keywords there. Now, number 3. What are 2 events that happened before the International Space Station was assembled? Oh, what's the trickiest part of this question? What do you think, Lucy? What's the trickiest part? It says, what are 2 events that happened before the International Space Station was assembled? What's the tricky part here?
Go back.
It says, more than 2 were there.
There might be, so there's definitely more than 2, but you have to choose 2, right? So I want you to, before the International Space Station was assembled, I want you to talk at your table. U.S. created a space station, Artemis missions began, NASA conducts ongoing missions, Hubble telescope was launched. Talk with your table. Oh, let's put this up. Let's see. You have 10 seconds to talk with your table. What do you think?
It's Hubble and NASA. I think the 99.
We got ours.
Me too. Guys. If we get picked, then choose Hubble. Artemis. Artemis is
2,
wrong.
1,
They're not on this.
and 0. Voices should be off. Here's what I need from you, my friends. I'm going to tell you a choice. If you agree, if you think that's one of the two, give me a thumbs up. If you think it is not, give me a thumbs down. Okay, so let's see how we do. The U.S. created a space station. Did that happen before the International Space Station was assembled?
Yes.
Thumbs up if you think yes. I don't have everybody's thumbs. Thumbs down if you think no. I see lots of yeses, so I'll choose that. Before the ISS was assembled, what did Artemis missions begin? Yes or no?
Oh.
I see lots of no's. Why is this answer no?
Because it's the one that was from today.
Because that's today, right? NASA conducts ongoing missions for ISS. Yes or no?
No.
Oh, I see some, did I see some questioning? I see Chloe is like, definitely, we have people who aren't sure. Chloe, you say no. Why not?
Because isn't that the one that we're working on? That we're doing?
It's not even on the
So,
map.
there's two things here. Eyes up here, friends, because Chloe's right. The people are right. This is a confusing one. Our question is, the International Space Station was assembled. If you look here, that happened in the 2000s. It says it right there. But here we have ongoing missions for ISS. If we look at the bigger version, where are the ongoing missions for ISS?
Oh,
Right here, okay, right here. So Chloe said no, absolutely not, and guess what? Chloe was right, that's not. What about yes or no? The Hubble telescope was launched before the International Space Station was assembled. I see lots of yeses. Let's choose that. And going on to the last question here. The last time astronauts walked on the moon was 1972, also before I was born. If you were going to put this event on the timeline, which two events would it be between? We have the NASA launch, the Apollo 2
Yup.
moon landing, Hubble launch,
Hubble.
ISS launch, or Artemis missions. I'm going to put up the big picture. Where would you put 1972 on this timeline? Talk at your table.
So don't we see that 1960 is right there with Apollo 2 and Hubble bubble is right there with the 1990. And between that would be 1970 between 1980. So it's Apollo 2 moon landing and it's Hubble bubble. There.
Okay, 4, 3, 2, 1, and 0. I heard lots of ideas. Malik, do you think you know?
Yeah.
All right, let's get you up there. You're going to choose my correct answer. Come on up. Choose which two events. So Malik says between the Apollo 2 moon landing and the Hubble telescope design and launch. If you agree with Malik, give him a thumbs up.
Yeah.
If you don't, give him a thumbs down. Looks like you are correct, Malik. Thank you.
Yeah.
Ow. So again, friends, everything you need is here. It may not say it on here. We don't have the 1970s on there. But the information you need to answer it is there. We will continue working with timelines. You will have your next data literacy quiz on Tuesday, I believe. Okay? Nope.
Tuesday?
Wednesday. Wednesday. Relax. Okay, the next thing I want to talk about is this. What does this look like?
Oh, the thing that
The molecules from the simulation. You worked through this last week when I was gone. I'm going to give you a copy of just this with a couple questions. The first thing I'd like you to do is put your name on it because we only have about 5 minutes before we transition. Okay? So put your name on it. Do not start answering questions or drawing in the model. You're welcome. simulation? Okay. All right, that's most of you.
Wasn't it Friday?
It was
It was
Thursday.
Thursday.
Last Thursday?
So most of you were here. I do have a few people who weren't. We're going to spend about a minute and a half with you talking at your tables, reviewing what you saw in the investigation, in the simulation, with your table. So my friends who weren't here, Moa and Isabella, you're gonna, oh, you were here, okay. You're gonna listen to your partners. So quick, 1.5 minutes for you to talk with your table. What did you see in the simulation with the
So,
molecules?
what I saw in the simulation when it was like not move that much, and then when it was at 500, it would move like what is that?
That means where? Your turn.
Ooh, sounds like we're ready to go with 30 seconds left. Eyes on me in 3, 2, 1. Oh, I forgot to show you your score. Let's do this real fast. Let's look at the score of your test, of your quiz.
0.
Oh, 100%. Nice job.
47 minutes.
Okay.
I took 4 minutes.
It took me 10 hours.
It took me 3
All right. So when we look at this, help me set this up real fast so we can do a quick talk about it. What molecule did we use?
Water.
I want to use water. There's one more thing we have to change.
Liquid.
No.
Oh, that's
Celsius.
Celsius.
I want.
To Celsius.
I have to change from Kelvin to
Celsius.
Celsius. Scientists use Kelvin. We don't need to use Kelvin in fifth grade. So this model that we have here, shows something's happening. Okay. This model shows the investigation you did. What does the model show just as it is?
Just a blank paper.
It shows a blank paper, but the model in it means something. What does the model inside this blank paper tell me to do, Samuel? What does it tell me to do? What did you do first in your investigation on Thursday? Right here, this tells us the temperature we want. We want to see 500 degrees Celsius. So I'm going to come back to my simulation. How am I going to turn this to 500 degrees Celsius? Salt?
Heat.
I'm going to add some heat. So if we go, it's going up towards 500. Pay attention to what's happening here, my friends, to these molecules. You start to see them moving.
They're spreading.
Move apart from each other.
Moving apart, they're spreading around. And what else starts to happen?
They
go to the top. Why don't they go out of the container?
It's
closed.
Yeah, there's a lid. This is called a closed system. So you're right. When you said it's closed, that's exactly right. It's a closed system. And here we are just over 500. So there's two pieces of information we see here. The first thing we see is that they're moving very fast. The second thing we see is that they're going up. What does your model tell you to do next?
We have to
bring it down to 0.
We have to drop the temperature to 0. Real quick, I want you to see what happens as we go down to 0.
It's slowing down.
Slowing down.
As it slows down, they move it back down.
They're moving back down. And this is a pattern that no matter how many times we do this, we would see the same pattern. We're getting there. So tomorrow we are going to start with this sim model. Tomorrow we are going to start by looking at the pattern. What happens as we go to 500 degrees? Sit down, please. I'm not done. What happens as we go from 500 down to 0? This paper needs to go in your binder in your science section. Then you can gather your things and line up, please.